We are doing carbon and its compounds, and today we will be doing some important organic compounds. Okay, organic compound means compounds of carbon or hydrocarbons. Okay, all terms are same: hydrocarbon, organic compound, carbon compounds. So, first compound which is given in your NCRT book is ethanol. What is ethanol? Ethanol is what? C2H5OH. This is ethanol. And in our day-to-day life, it is called as alcohol. So whenever the normal term alcohol is used, it's well understood it is ethanol. Like for example, you must have seen on the cough syrups most of the cough syrup, they have alcohol content or some amount of alcohol. So what is that? That alcohol is basically C2H5OH or ethanol. Now, pure C2H5OH, that is without any amount of water or any substance added, this is called as absolute alcohol. So, if someone asks you what is absolute alcohol, it is nothing but the purest form of ethanol. Now, we have listed here some of the properties of ethanol, which you have to keep in mind. One thing, it is liquid at room temperature. Second, these are the boiling and the melting point. Okay, and what we have, it is a very good solvent. That means ethanol dissolve not only the hydrocarbon but some of the other compounds which are ionic in nature. Okay, and therefore it is very important for medicine industry. And in different medicine, as I told you, cough syrup, they are having alcohol content. And it is used in tincture iodine. You must have seen that when we have any injury or any open wound is there, we apply tincture iodine to disinfect that area. And what is tincture iodine? Tincture iodine is basically 2 to 3% iodine, very small amount of iodine, with potassium iodide or sodium iodide and a solution in a mixture of alcohol and water. So we take alcohol and water, and in that we add iodine with potassium iodide or sodium iodide. This is called as tincture iodine. Okay, this is, you can find this tincture iodine in any chemist shop. Now, one more term is used, that is denatured alcohol. What is denatured alcohol? You know, alcohol causes drunkenness. That is, you will lose your consciousness and it will affect the central nervous system. So all the motor skills as well as the thinking capability of person is affected if that person consumes alcohol. So to avoid misuse of alcohol, in ethanol, some amount of toxin substances or bad tasting substances are added. Like for example, ethanol is sometimes have a small amount of methanol, and methanol is poisonous. You remember this, that very important, that methanol, which is CH3OH, is poisonous in nature. Okay, so therefore denatured alcohol is what? Is basically, denatured alcohol is the alcohol which contains some amount of poisonous methanol in it. And why it is done? To avoid misuse of alcohol. Next important idea is that it is soluble in water. It is an hydrocarbon, but it is easily soluble in water. And people consume alcohol, and which affect their central nervous system. Now, we will discuss some of the reactions of ethanol. The first reaction, that is reaction with sodium. Sodium is a reactive metal, you know, and you must have done in metals and non-metal that sodium is a reactive metal. It reacts with acids to liberate hydrogen gas. Yes, in the same manner, your ethanol also reacts with sodium to liberate hydrogen. What is the meaning of this? It means, this is ethanol. it means your ethanol is slightly acidic in nature. Okay, and the product which is formed here is called as sodium ethoxide. Okay, sodium ethoxide. And this experiment we can do in lab. For example, in a test tube we take some ethanol, okay, and in this ethanol we add a small piece of sodium metal. Okay, we have added small piece of sodium metal. So what you observe, after some times that small bubbles are formed in ethanol, and when these bubbles they come out of the solution, how can we check that what is these bubbles? These bubbles are basically bubbles of hydrogen gas. Hydrogen gas is involved in this reaction where sodium metal is reacting with ethanol, and it can be checked as we did in case of reactions of metal. What will happen if we bring a burning matchstick near the mouth of the test tube? At that very moment when we are bringing about the reaction, we will get a pop sound. So pop sound is a confirmation that hydrogen gas is evolved. Next reaction is the dehydration reaction. Dehydration. First we will break the term. The first part, that is hydration. Hydration is what? Addition of water. And dehydration is what? Removal of water. Okay, so this is basically what? Removal of water. How we can remove the water? When ethanol is treated with hot concentrated sulfuric acid in large amount, we are heating here. This triangular symbol depict heat. So we will be getting an alkene, that is ethene. Okay, and water molecule will be removed. How this reaction will be taking place? If we write ethanol molecule, so this is your ethanol molecule. These are hydrogen atoms. This is hydrogen. Here also we have hydrogen, and here we are having OH. So what happens? This H from here and OH from the neighboring atom are removed, and they will give you what? H2O. And one valency will be free on this carbon, one will be free on this carbon. Therefore, they will form a double bond here. So we'll get a ethene. And here your concentrated sulfuric acid is called as dehydrating agent. Okay, sometimes to bring about a specific reaction, a specific reagent is used. So here the one which helps us to bring about dehydration is called as dehydrating agent. Okay, like for example, we in the oxidation reaction we have used oxidizing agent. Now other properties. When large quantity of alcohol is consumed, then what happens? It will slow down the metabolic process and it will depress the central nervous system. Okay, so a person will not be in his senses when a large quantity of alcohol consumption is there. Next, ethanol is important industrial solvent. This is very important, and to make sure it is used industrially for good purpose like for medicine etc., we make denatured alcohol as we discussed. And to prevent misuse, it is denatured by adding methanol. Okay, one more process. We can produce ethanol from sugarcane. And what we do, that we heat sugarcane juice, and after a concentrated juice or molasses will be produced, and this molasses when undergo fermentation process we will get ethanol. Okay, and last is sometimes nowadays in few places this is used as an additive in petrol. Why? Because it burns with no harmful gases, or we do not have any unwanted molecule of gases being produced after combustion. So therefore it is a cleaner fuel. As a result, it is used as an additive in petrol nowadays. Next compound that we have in your syllabus is ethanoic acid. And ethanoic acid in our common language is called as acetic acid. Now, ethanoic acid is a type of carboxylic acid, that is organic acid, or an acid which is an organic compound. Now, what are the properties? The first property, 5 to 8% solution of acetic acid in water is called as vinegar. So if someone asks you what is vinegar, that is 5 to 8% solution of acetic acid in water. And we use this as a preservative in pickles at home. That is, at home in kitchen, we use vinegar for many purposes. This is melting and boiling point. And since melting point is low, as you have seen, so what we found that it freezes in winters, okay? And when it freezes, it forms white crystal. So therefore, it is also called as glacial acetic acid. Okay, so what is glacial acetic acid? White crystal of acetic acid at low temperature are called as glacial acetic acid. Next is it is acidic in nature, and we can confirm this with pH paper. Okay, so but one thing keep in mind that it is a weak acid and it is weaker than mineral acid. What is mineral acid? Your hydrochloric acid, sulfuric acid, nitric acid, that is inorganic acid, are called as mineral acid. Okay, so it is weaker than these acids. All carboxylic acids are weaker than mineral acid. Mineral acids are strong acids. So accordingly, we will get different color. For example, if we take HCl, then we will be getting red color because it is strong acid with pH around 1. While your this weaker acid, that is ethanoic acid, we will be getting orangish color because pH is high, that is it is mostly between 2 and 4. Okay, so this is all about ethanoic acid. Next, some of the reactions of ethanoic acid. First reaction is called as esterification. Esterification means what is the meaning of term? Esterification means formation of ester. Okay, so when carboxylic acid is treated with alcohol, we will be getting ester. What is ester? We will discuss what is ester. So this esterification is what? Formation of ester. Esters are very sweet smelling substances. They have fruity smell like any fruit essence type of smell. And what is the reaction when your carboxylic acid react with alcohol? We will be getting a new substance that we call as ester. So what is ester? Have a look here. This is your ethanoic acid, CH3COOH, and this is your ethanol, that is alcohol. So what will happen? OH group from ethanoic acid and hydrogen atom from ethanol will combine to give you water molecule, and whatever is left will combine together to give new molecule that we call as ester. Okay, and have a look here, the part which is coming from acid and the part which is coming from your alcohol. They are combining together, and what is the functional group in this case? Functional group is this. This part is your functional group. We are having a C carbon having double bond with oxygen and a single bond with next oxygen, and on each side we are having a alkyl group. This is an alkyl group and this is the alkyl group. Sorry, it is not visible very much. So we'll keep it that way only. Okay. So this is an ester. This reaction takes place in the presence of an acid. And have you seen here, I have made your two-headed arrow. It means reaction is possible in forward direction as well as backward direction if we change the condition. Okay, so in this case we use catalyst, and our catalyst is what? An acid, a mineral acid. So in lab we can do this reaction. What we do here, we take your mixture of ethanol, acetic acid and few drops of mineral acid like sulfuric acid in a test tube. We have taken in this test tube, and this test tube we heat in a water bath. What is water bath? We take in a large vessel some water, and the solution that we have to heat we keep in the water, and then we heat this solution. Okay, so it is indirect heating. After heating for some times of few minutes, suppose 5 minutes, what we do, this solution we will pour into another beaker containing 20 to 50 ml of water, and as soon as we pour this hot solution in water, we will be able to smell something very sweet or fruity. And what is that? That is ester. So here ester is formed, or this is what? Esterification reaction. Next reaction is saponification. Saponification is just reverse of esterification. What we are getting in esterification? Alcohol and carboxylic acid is giving you an ester. Here what we do, an ester is when treated with a base, it will give you back alcohol and salt of carboxylic acid. So what we are getting here, we are getting back the salt of carboxylic acid, we are getting back alcohol which we have used, and what we will do, we will bring about this breakdown of ester which we formed earlier with the help of what we are using, with the help of an alkali or base. Alkali or base, like for example sodium hydroxide, like here sodium hydroxide is a base or alkali. You know what why few bases are called alkali? Because the bases which are soluble in water, they form basic solution, and these soluble bases are called as alkalis. Now next, what is this sodium salt of carboxylic acid? This one, salt of carboxylic acid. We will not get carboxylic acid, but salt of carboxylic acid. This salt of carboxylic acid is nothing but just like a soap molecule, and therefore this reaction is called as saponification. Okay, because this reaction is used in the preparation of soap. What is soap? Soap is sodium or potassium salt of long chain carboxylic acid or fatty acid. We discuss what are fatty acid. Those carboxylic acid which have long hydrocarbon chain or which have large number of carbon atoms are called as fatty acid. And when we make sodium or potassium salt of these acid, we call it as fatty acid. Sorry, we call it as soap. Here we have given one of the example that is of the same. Here we have an ester, this one, and when we treat it with a base, we will be getting back alcohol, that is ethanol, and we will get sodium salt of ethanoic acid or sodium salt of acetic acid. Why we are getting sodium salt? Because in medium, when we have NaOH in the medium, we will be having Na plus ion and OH minus ion. Okay, and acid has got H plus ion. So H plus and OH will give you H2O, and sodium will come here. Next reaction is reaction with base. Okay, and since it is acidic in nature, although it is weak acid, so your ethanoic acid will react with a base to give you a salt. Okay, we are getting a salt here. So this salt is sodium ethoxide. It is just like this reaction. I'm writing here HCl, for example, when react with NaOH, we will be getting what we are having, NaCl plus H2O. So when acid base react, we have what? A neutralization reaction. Product is a what? Salt. In the same manner here we will be getting salt. What is the difference? Here we are having chloride ion produced from the acid, while here we are getting what? Acetate ion produced from acetic acid. Okay. Next reaction is reaction with carbonate and hydrogen carbonate. Now your carboxylic acid, they react with the carbonate or hydrogen carbonate to give you salt, carbon dioxide and water. Now whether it is carbonate or hydrogen carbonate, you have to remember in both the cases carbon dioxide gases evolve. So what is the reaction? Here your acetic acid is reacting with your sodium carbonate to give you sodium acetate and carbon dioxide gases evolve. While acetic acid will react with sodium bicarbonate again to give you sodium acetate and carbon dioxide gases evolve. Okay. The only difference between these two reactions is that number of your acetic acid molecule used and amount of carbon dioxide produced. Otherwise, both the reactions are same. Now, these reactions we can do in lab, and we can check whether carbon dioxide gas is produced or not. So, what we do here in a test tube, we will be getting your a solution of ethanoic acid, okay, and in this solution we are adding sodium carbonate. As soon as we add sodium carbonate, ethanoic acid solution will be liquid and sodium carbonate will be a solid. So when we are adding this, what will happen? Some gas will be produced, and this gas will go through delivery tube into another test tube which is containing lime water. What is lime water? Lime water is your a solution of calcium hydroxide. Okay, this is lime water. So this lime water will react with, that is your what is lime water here? Calcium hydroxide solution, that is CaOH whole twice. It will react with carbon dioxide produced in this reaction, this the carbon dioxide produced, and it will give you CaCO3, calcium carbonate, which is white in color. Okay, so therefore lime water will turn milky. Why? Because of the reaction of carbon dioxide with lime water, that is calcium carbonate. Okay. Next reaction. Now we are doing last topic of this chapter, that is soap and detergent. And before discussing in detail about what is soap and what is detergent chemically, let us have a look on this activity. Here we have taken two test tube. In each test tube we have taken 10 ml of water, and we have added few drops of oil in each test tube. You can take any oil. When we keep these two liquid in each test tube, that is A and B, what we have observed that oil and water, they form separate layer. They will not mix with each other, or they are not miscible with each other. So why they are not mixing with each other? For mixing or for making solution, we have to keep one rule in mind. What is that rule? Like dissolves like. That means, what is the meaning of this? Like dissolves like. It means that if we have any ionic substance, like for example sodium chloride, which is made up of oppositely charged ion, it is soluble only in similar type of solvent which we call as polar solvent, and one of the Best example of polar solvent is our universal solvent, which is water. Water is having ionic character, therefore sodium chloride is soluble in water. But your organic substances, like for example oil or any hydrocarbon, they are soluble only in organic solvent. Okay, they are not soluble in water. Organic solvent, like for example alcohol. And this is according to this rule, like dissolves like. Fine. So your oil is not mixing with water because one is organic, another one is ionic in character. So they are immiscible with each other. They will keep themselves in the form of separate layer when we are keeping them together. Now what we do in the next step, that for first test tube, that is A, will keep as such, but in test tube number B, we will be adding few drops of soap solution. And after this, we will shake vigorously both the test tubes. So once we stop shaking, after few seconds, what we observe in test tube number A, your oil and your water will form again separate layer. They will appear to be forming an emulsion till we keep on shaking. Once we stop shaking, then they will form separate layer. Why? Because oil will not dissolve in water. All oil is immiscible with water. What is the reason? Reason is this. We have discussed already. Okay. But in test tube number B, we even after shaking and keeping it for some time, we are able to see a very stable emulsion, and this emulsion is stable for a quite long period of time. And why this emulsion is formed? Why we are not having separate layer of oil and water in test tube B? Why? Because soap will help to form emulsion of water and oil. So soap is acting as a emulsifying agent, or it is helping in the emulsion formation. So question is, why soap is able to form emulsion? So this we will understand when we look into the structure and line of action, how soap will act or how it will show its properties. Soap, as we discussed in saponification, is sodium or potassium salt of fatty acid. What are fatty acid? Long chain carboxylic acids are called as fatty acid. And we have represented different hydrocarbon by different formula, as we discussed in IUPAC nomenclature. One of the way of representing any hydrocarbon when we have big molecule, that we can show carbon bonds with the help of lines. This is bond line structure. And here it is easy to represent. Why? Because in the case of big molecule, it will be very tedious to write large number of carbon atom. Fine. Now come to the soap molecule. As we have written, they are sodium or potassium salt of your long chain carboxylic acid. So here we are having a soap molecule, and this soap molecule is having a hydrocarbon chain here, like this molecule. And this hydrocarbon chain is hydrophobic in nature. That is, it will try to keep itself away from water. It will hate water, or it will not be oriented towards water. Okay. So this hydrophobic tail, which is water hating, it is why it is hating water. Reason is it is what? It is organic in nature, and we have discussed that organic compounds are soluble in organic solvent. So therefore this hydrocarbon tail will be attracted towards oily dirt which we have on our cloth. Why? Because oil is organic and your hydrocarbon chain is also organic. In the same manner, your ionic part, this part is the ionic part of your soap molecule, and this ionic part is what? Having charge. It is ionic, it is having negative charge, and your Na plus ion will get dissolved in water, just like we have NaCl. When we add NaCl in water, we have Na plus Cl minus. In the same manner, here when we are dissolving soap, this Na plus will get dissolved, separated from this part of the molecule. Okay, so ionic head is basically this part. Fine. This is your hydrophilic end or water loving end. And this hydrophilic end will be attracted towards what? It will be attracted towards water. Okay, reason, it is ionic and it will be soluble in polar solvent. So therefore it is hydrophilic, and this part is hydrophobic. Now, how soap help to clean dirt or to clean clothes or other article? What is the line of action of soap? So when we are using for soap for cleaning anything, then in water soap molecules will form micelle. Why? Because hydrophobic tail will remain away from water, and it is only possible when they form a spherical aggregate, which we call as micelle in water. So what happens? This hydrophobic tail, they will attach themselves with dirt, which is also organic in nature, and they will be in the center of spherical arrangement, while your ionic part will be on the surface because it is hydrophilic, it is water loving. Okay, so it will be oriented towards water. So in water, soap molecule will form micelle because hydrophobic tail will remain away from water and in the center with oil. And what happens to what you have hydrophilic ends? Hydrophilic ends will be on the surface of spherical arrangement. Okay, so this leads in the formation of micelle. And what is micelle? Micelle is cluster of soap molecule in which hydrophobic tails are in the interior and ionic ends are on the surface. Hydrophobic tails are interior and hydrophilic ends are on the surface. And how this micelle formation help to clean anything? Okay, so when we are cleaning any article or any cloth with soap or soap solution, so what happens? Your oily dirt will be collected in the center of micelle, and micelle will stay in solution as a colloid. Okay, large molecule, it is large molecule, and will not come together to precipitate due to ion-ion repulsion. Thus, dirt suspended in the micelle is easily rinsed away. Okay, what is the meaning of this ion-ion repulsion? So have a look here. In this case, I have shown here two micelle or two clusters. In one cluster, this one, and second one in water. And in water, when we are cleaning with soap, there will be variety of such type of clusters. So what we are having here, this micelle is having negative charge on its surface. Second micelle is also having negative charge on its surface, and you know the like charges repel each other. So therefore one micelle will try to keep away from the other micelle molecule. Therefore they are not joining together. As a result, they will not be precipitating. Now you will ask me, where is Na plus? Na plus will be free in the solution as free positive ion. It is just like when we dissolve, for example, we dissolve NaCl in water. So we are having free Na plus and free Cl minus, just like that. So this is how your soap is helping to clean dirt. Now, one thing which you have to keep in mind that soap solution, why soap solution appear cloudy? It is not clear, just like water. Why? Because micelles are large molecule and therefore they scatter light. You must have studied the colloidal solution in case of your 9th grade when you have studied solution, suspension and colloids. There is one problem with soap molecule. When soap is used with hard water, then lots of soap is wasted. Why it is wasted? Because it forms insoluble scum. So first we will understand what is hard water. Hard water is basically water containing dissolved salts of calcium and magnesium. These salts may be as bicarbonate, chloride or sulfate. Like for example, calcium chloride. For example, magnesium sulfate. Okay, so these salts are there in dissoluble form in water. This water is called as hard water. And this water react with soap to form insoluble scum. So therefore, lots of soap will be wasted in overcoming this hardness. As a result, we need larger amount of soap to clean anything in case we are using hard water. This problem is overcome by using detergent, another class of compound, and detergents nowadays are found in shampoos and the products which are used for cleaning clothes. So we are here comparing what is detergent and what is soap. We have discussed soap is sodium or potassium salt of long chain carboxylic acid, which we call as fatty acid, while your detergent is sodium salt of sulfonic acid. This sulfonic acid is what? This sulfonic acid is inorganic acid, okay, or mineral acid, while your carboxylic acid is organic acid. So they will have different properties. Fine. Your soap molecule, as we discussed earlier, has got hydrophobic tail. In the same manner, your detergent also have long hydrocarbon chain which is acting as a hydrophobic tail. But ionic part in both the cases is different. Here ionic end is carboxylate ion, while here ionic end is sulfonic acid group, which is inorganic in nature. Okay, so how they are acting, they will act differently because their nature is different. Therefore, your ionic end of detergent will not form insoluble scum with calcium or magnesium salt. Therefore, detergent is required in small amount and it will clean article in a better way. While soap molecule in hard water will form scum or insoluble scum by reaction with calcium or magnesium salt, which are present as hardness, and thus lots of soap is wasted. So using soap is not economical. Side by side, articles which are we have to clean with soap, they feel very sticky because of the presence of this scum. Okay, so detergent is better than soap because of this reason. So this is all for carbon and its compound. This finishes our chapter.